Hello everyone. Welcome back to my YouTube channel. Today I will share with you some information about batteries and wind power equipment. I am currently using a 48 volts battery system. This battery is lithium iron phosphate. Iron phosphate. I am using a 10A balancer. This battery has a capacity of 340A. And a BMS, battery management system, that protects it at 250A. This is wind power. Currently, the wind is weak. I run the wind power system through the MPPT solar charger. Charge one output at 24 volts. Separate one output at 24 volts. This is weak land wind. The weak land wind is entering the charging flow. Weak wind voltage is fluctuating. This is the rectifier bridge. Wind power is entering through the rectifier bridge to take direct current. And this is the output. Supplying to the battery. I am supplying one output at 24 volts. The rest is used with an inverter. The inverter is still charging from the solar inverter. I have been using this inverter in combination. Solar energy is going down, and it is in priority mode. The preferred power source is from the sun and it never runs out of sunshine. When wind and grid power are lost, then solar power is also lost. AHTHE grid electricity is functioning. The grid only activates when solar power is lost, switching to green mode, while this one is in priority mode. Solar power in this battery, and now, I will go up and film how the wind power system is operating for everyone, outside by the power pole, out here. This is the pole. The wind is very light, everyone. Right now, the wind is very light. You can all see. The wind is indeed very light. The wind is very light here at wind power site. Soon, I will install the gearbox. I will install the gearbox soon. I am in the process of installing the drop head on it. The drop in the front. Alright, okay, let's go up to the roof, up there. It's easier to film downwards. Filming upwards from down here is a bit high. It's a bit hard to see, so let's continue back to the wind power pole. Stand there, the rooftop turns down. Stand there, the rooftop turns up, then it's closer. Here, you can see this rotor that we made with 4 blades. 2 long blades and 2 short blades. 2 blades are 1.6 meters. 6 meters. And 2 blades are 2 meters. I see that the wind power is very small, but the blade still rotates relatively well, so we are considering to replace those 2 short blades with 2 long blades of 2.5 meters, and install it through a gearbox. Increase the speed by 3 times. The gearbox will turn 1 revolution. The generator unit will turn 3 revolutions, to increase the rotational speed, so we can use the 48 volts battery system. Currently, our battery system is using a 48 volts battery. With wind like this, it only generates 1517 volts. With this rotation speed, it can reach 24 volts, 25 volts. Everyone can see. This is the generator. 200 RPM. RPM is 200, with an output voltage of 48 volts. And the power is 1 kilowatt. But currently, with such low wind, it can only generate a few tens of watts to a few hundred watts. Wind speed like this. Charging at 24 volts can generate around 200 W. At 48 volts, it can only generate 100 W. This is. I will upgrade the gearbox. Upgrade the gearbox. There, you can see. The wind is very normal. This wind speed is just normal. We can see the pole. It sways back and forth, just a little. It's not ordinary. I will replace the blades from 2 meters to 2. This 5 meters blade is entirely made from steel. From wood, making blades entirely out of wood. I will post a video on how to make this blade for everyone to see. Wooden blades are more durable. It is more stable and will be sturdier than composite blades. The factory blades are double wooden blades fused together. This generator unit weighs 50 kilograms along with 2 wooden blades. Each one weighs 12 kilograms. Each blade made of wood weighs 12 kilograms, and there are 2 composite blades from China. I bought it, and it weighs 16 kilograms. Those are the two blade mounting plates. The wind speed is quite normal. The disc goes in. This disc is for the generator unit. This large disc is thick. It is made of 1.6 centimeters thick steel plate. It has a diameter of 16 millimeters and a width of 50 centimeters. The outer plate also has a diameter of 50 centimeters and is 1 centimeter thick. Those two discs weigh over 30 kilograms, and the shaft attached to that disc weighs another 5 kilograms. Altogether, this wind turbine assembly is close to 80 kilograms, almost 80 kilograms, and the generator unit weighs 50 kilograms. The tail of the wind vane at the back weighs another 50 kilograms. Here, the wind is always steady, but it's only small like this, so I will raise the blades, and you all will give me your feedback. This is the plate for mounting the blades inside, the plate for attaching the inner blades. Please give me your suggestions, and let me know how to proceed. I have also just switched to wind power. It's been a year, but I really enjoy wind power. There are many things to research, experiment, innovate, get filming, going to film. The way to erect this power pole is also done automatically. Normally, the power pole will be lowered horizontally. It is this tall. The cable lines are positioned at those corners. Cables like those. Release it, and the power pole will lie horizontally like this. Here is the generator unit powered by water. The water-powered generator. The power pole will lie horizontally. That water is for the electricity, the hoist. Hoist. From top to bottom. Use this hoist. The power pole lies horizontally like this. Use this hoist. Press the controller to make it operate. If you release it, the power pole will lie horizontally like this. Currently, this power pole weighs over 1 ton. This pillar. Diameter 280. Diameter 280, thickness 1.5 centimeters. It is 13 meters tall. It is 13 meters tall. It weighs over 1 ton. And with all the equipment added, it weighs about 1.5 to 2 tons. 5 tons. Here's the bullet level. Because the tail spins with the wind, you know. The blades of the generator unit. It is 500 kilogram. So it is equivalent to 1.5 tons. Before, I would pull by hand. I used my hands to pull the chain. In the past, I used my hands to pull the chain to lift and lower the utility pole. The pulling time was very long. Each time it took 2 to 3 hours to pull. Then I modified this hoist machine. Here, this electric hoist. I modified it as well. I modified it into an electric hoist and used a controller. 10-ton hoist. I will go down and film the details for everyone to see this hoist. Load of 10 tons. I modified it into an electric winch, supplying 48 volts power to the 3-phase motor. This motor is 3-phase. Power supply 48 volts. This 3-phase motor pulls this. Three-phase motor 1 kilowatt. The voltage of this pulling motor is 200 volts 3-phase, but I'm only using 48 volts, so it runs quite well. I'll go down now, and I'll show everyone. Here, I have climbed up. This is the electric hoist. This is the motor. 200 volts 3-phase. 200 volts. Servo motor. AC servo. And I've used this one. I converted it to run on 48 volts power. Running on 48 volts voltage. Running on 48 volts voltage. Quite good as well. Using through 2 stages. Here, buy the sprocket set from a motorcycle. Take a small sprocket from the motorcycle. Mount it on the shaft of the pulling motor. And the hoist. Then take the rear disc of the wheel. Install it here. And cut off the chain. After that, I will use the controller below. Power supply and through the inverter. The controller of the electric bicycle motor. There's the electric bicycle motor over there. 60 to 72 volt system. 60 to 72 volt controller. And that line. It is the line. 2000 W. Actually, it is 1800 W. But it only consumes 1000. At that time, I will use this to pull it. That horizontal pole down there. This wind power pole. When it lies horizontally in that yard, it is very heavy. It weighs several tons. It weighs about 10 tons. So I will use this large hoist. 10-ton hoist. This hoist is heavy. This is a 10-ton load hoist. When we use the hoist, it is very strong. It is strong, unlike a crane. Or an electric hoist. The hoist is stronger than the electric one. And its locking mechanism is safer. I can rotate it in and out. It even has a reverse lock. The hoist has a locking mechanism as well. For the power pole, I can lower and raise the foot. These are the steps. If the steps go up to the top, whenever I need to handle it, I will use this staircase to go up. Whenever we need to handle an issue and want to lower it to avoid storms, I will use this wind power system to lower it down. This wind power system. At that point, I will lower this pole horizontally down there. Look, that cover is supporting it. Alright, okay, I'm sharing this with everyone up to this point. I'm going down to film the lower part. Here, I've come down now. This is the pull base and the lever. Pull base. And this is the lever. The lever can be raised and lowered. This lever will be a very large key pin. Diameter 50. For welding, we will use structural welding. Here, we will use all structural welding. All will be structural welding. This is the concrete base. It is buried 3 meters deep underground. It is buried 3 meters deep underground. 8 concrete blocks are located underneath. The square has arrived out there, out here, and the remaining part is the top connection. This is the column steel. The column steel is 1 centimeter thick. All this steel is 1 centimeter thick. The body of the round pipe. The diameter is a pipe of 72, 73. The remaining part is this flange, 6 centimeters thick, up to 2 centimeters. These are the braces, the supporting brace, and the brace that increases rigidity. To prevent lowering, our welds are made like this. Remember to subscribe to the channel, okay, family? The paths have no sand. Underneath this is concrete 2 meters deep underneath this. These holes below have 2 meters of concrete. Deep down is 2 concrete blocks. This is the cap to support. The paths have no sand. Underneath this is concrete 2 meters deep underneath this. These holes below have 2 meters of concrete. Deep down is 2 concrete blocks. This is the cap to support. To support this cap when that column lowers down, it will be placed here and operate the fan blade cover up there. It's currently on the ground like before. This pole of ours is currently tall. We're connecting another piece to it, 1.5 meters. But when you look up at it, it seems too high. We are lowering it again. Here is another machine. A generator running on water. It's currently under construction. This is the ongoing work on the water power generator. Do you all see how high it is? It is relatively high. It's quite high, isn't it, everyone? My phone screen is blurry. It's too dark. My device must be hot. I will end the video here. I will handle the phone, and I will post it for everyone to see.